welcome to the ICS 103 programming course again. This is lecture number 2 where I will be giving an introduction to C. So let's start. So the outline of this lecture is that we will basically give an overview of C, and then we'll talk about the history and the philosophy, why do we use C, what's missing, general form of C programs, C language elements. Then we're going to talk about the preprocessor directives, the comments, the main function, the variable declaration and data types. And unfortunately after that I'll be out of time. There will be 3 more topics that I want to talk about, which is the executable statements, reserved word identifiers, but I'll leave that for the next class. Okay? So this is basically what we're going to be learning today, and this is a basic introduction to C. So, a bit of a history of C. C was actually developed in 1972 by Dennis Rich. Okay? He was working at AT&T Lab, or Bell Labs at that time, and it actually was built for the operating system of Unix. Okay? So this is where actually the C came from. It is by far the most commonly used programming language in writing system software. Okay? So system softwares are usually software that do not have a user interface and they're running on the background. So always C sits on the background and runs so that you can have a very fast and efficient code running. Okay? C is machine independent. Okay? You can compile it on a variety of machines and you can run it on almost any machine that you can actually imagine. Sometimes you might have to do a minimal change to the source code when you compile from one machine to another. However, in this class, whatever source code you're going to produce will not have very much effect if you're going to compile it on different machines. Okay? And it can be compiled on a wide variety of platforms and operating systems, since there's compilers for different operating systems. There's a compiler for Linux, there's a compiler for Unix, there's a compiler for Windows. You can actually compile it on any program and run it on any operating system. Okay? There's also a compiler for C, I think on the Android and the Mac operating system. So, the question comes, why are we taking C? Many companies, research projects, do all their programming in C, and this is a fact. Okay, so companies are still using C programming, and lots of research projects are also using programming in C. For example, some of the simulation tools can actually, like MATLAB, can actually take C code and they can actually run a very fast code inside C. Okay. The second reason, that it looks good on your resume. So when you graduate from the university, you can actually go and put that you are a C programmer. It looks very good and it attracts people from the industry. Okay. C has a very small and compact code. This is very important. The code is very small and compact. So if you have memory problems, such as in your mobile phones when you're doing a program, and there's a very limited memory and you want a very compact code, C is very good tools because it basically produces a very small code, so you can actually upload it into the small space that you have in your machine. Okay, it's a procedure optimized program that runs very fast. One of the best things about C that it runs very fast. Okay, it's actually talking to the hardware directly, and that's the fastest you can get into running any program from any higher level language. It is faster than Java and all the other programming languages that actually run on a virtual machine, which makes it a bit slower. Okay. It also gives you a low-level access to the computer memory, so your program can access the memory of the computer via machine address and pointers, and we're going to teach you how to do that. Whereas in other languages, they do not give you the facility to go to the memory of the computer and actually control it. Okay. The good thing about C, it's for low-level, bitwise programming. So if you are actually wanting to write a program that goes bitwise, you have to go to C, and we actually define the bit to be the smallest size of the memory. So if you're going to the smallest size of the memory and you want to work on it, then C is a very good programming language that can actually help you do that. It can be compiled on a variety of computers. Okay, so you can actually have compilers on different computers and it will run on different machines. Okay, so let's talk about what's missing in C. Okay, so there is poor error detection, which makes it difficult for beginners. Okay, an error detection, when we write a code in C and we give it to the compiler to compile, if the compiler doesn't understand what's going on, then it generates an error. The error it generates is not specific. It's a general error basically, and you will have to be an expert to know what the error is. Okay, and you'll face this into the labs that you do in the course. So it generates an error, and maybe it generates an error on a wrong location. So maybe it says the error is on line 5, whereas actually the error is on line 4. Okay, so you have to be an expert to know what type of error it generates and how to fix them. Okay, so this is one of the bad things. Other programming languages might have more specific error generation, and I'll tell you exactly what's the error, but over here it's not going to tell you what the exact error is. Okay, there is no automatic garbage collection. What is garbage collection? Garbage collection is a memory management technique. Okay, and the memory management technique and garbage collection, you don't care about the memory. Okay, and you start creating variables and deleting it, and the garbage collector is what actually manages the memory for you. So if you delete a memory, it goes and wipes that memory out for you. In C, there is no garbage collector. In C, you are the master. Okay, so you control the memory. You tell it what to do. If you tell it to do something, the computer is going to do it for you into the memory. If you access a memory that is outside your variable, the computer is going to allow you to access it. You are the expert. If you say you want to access it, that means that the computer should access it. That is why there is no garbage collection in C, because you are the expert. So you tell it where the variable is and where you want to store it, and if you want to delete that variable, it's supposed to tell it to delete that variable. So there is no garbage collection because you are an expert. Okay, there is no bound checking of arrays and allocated memory segments. Okay, another thing in C is if you are allocated a memory for something and you go out of it, the compiler is going to say you're the expert. If you want me to go out of it, I'll go. If you don't want me to go out of it, you should give me a command to stop. Okay, so there is no memory bound checking in C because the computer or the compiler treats you as the programmer. You are the expert. You know what you're doing. If you want me to go outside, I will go outside, and I will write wherever you tell me to do, and I will change the memory in whatever means you ask me to do it. Okay. There's no exception handling in C. What is an exception? An exception is something when you're doing a mathematical operation and you come to an undefined value, just like dividing by 0. If you divide by 0, you get an unidentified number, okay, or not defined value. It's not a defined value. That is an exception. So if you do in any program divide by 0, the C program is going to stop. It's going to hang. It's not going to run anymore, okay? That is the problem, that it doesn't handle an exception. Why? Because again, you are the expert. If you are dividing by 0, you should have checked before that you're not dividing by 0. If you divide by 0, it's going to stop, and it's going to stop and say, oh, well, I got an undefined number, and it's not going to continue your program. Okay, so there is no exception handling in C. Okay, no native support for multi-threading and networking. What do we mean by multi-threading? Multi-threading is trying to run more than one program on your processor. Okay, so what it does is, if you have one processor and you're running two programs, for example, you're running an Internet Explorer and you're running, for example, the Firefox, okay, and you're running two different browsers. Or let's take another example. If you're running Internet Explorer and you're running Word, okay, Microsoft Word. So if you're running Internet Explorer, what will happen is that the machine is going to start the Internet Explorer, and it's going to then you run the Microsoft Word program. Is going to start Microsoft Word program, and then what's going to happen is that the machine is going to give a time allocation for program number 1 and a time allocation for program number 2, and then it rotates between them. So it gives 1 millisecond, for example, for the Internet Explorer, and gives 1 millisecond for Microsoft Word, and it keeps rotating 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond. And it does it in so fast manner, it does it so fast that you as the user don't feel the difference, and this is called multi-threading. Okay, so there is no multi-threading in the native C compiler. However, people have built some libraries which you can use to do multi-threading applications. Okay, the same thing goes for networking. When C was out in the 1972s, there was no concept of a network. No concept of a network came later on, so people introduced it in a library in C, which you can actually include into your program, and then you can actually do networking applications. Okay, there is no standard libraries for graphics and other application programming needs. Okay, so if you're looking for something fancy, like in Windows, when you click on the start button, you have something popping up, okay, and you have a nice visual graphical user interface, then C is not your program. C is basically for text input, text output, or something that runs in the background that works very fast. Okay, So, coming to the simple example in C program, this is a simple example in C program. This is a hello world program. Now, I do not know why people start with the hello world, but it is a practice in all programming to start with hello world, so I'm going to start with it also. So this is a hello world program, and what does the hello world program basically do? Any hello world program basically prints to the user hello world. Okay, so this is what it does. So this program is basically there just for printing hello world onto the screen to the user. Okay, so let's start and look at the code in details. Okay, so first of all, we have this line. We have the slash strike hello world.c space strike slash. Okay, now the slash strike is a special command for the compiler, telling it that this is a start of a comment. What is a comment? A comment is something that we tell the compiler skip or ignore. Okay, it's something we don't want you to look at. It is something that we write in English for ourselves. Okay, and we don't want the compiler to compile because it's not part of the source code. Okay, for example, if you are submitting a homework, or if you're doing some work and you want to post it on the internet, on the beginning of the file you put a slash star, and you'll put name, and you'll put your name, and you'll put your ID, and you'll put your ID, whatever other information that you want to put, you're going to type it in, and then you're going to put star slash, and all of this is, well, basically what you're telling the compiler is to ignore, from the star slash to the slash star, ignore everything in between these two. Okay, so this is what I'm telling the compiler, ignore this. This is not something. So when the compiler generates the object file or the machine code, it is going to skip this, whatever is between these two. Okay, then we have the first line is a hash include, and between these brackets we have the stdio.h. Okay, now hash include is called a directive. Okay, a preprocessed directive. Okay, any preprocessed directives in C starts with a hash. So whenever you see a hash, that's a preprocessed directive. So when you say hash include stdio.h, stdio.h stands for the standard input output library. So std is for standard, I is for input, is for output, and .h is indicating that it's a library. Okay, so hash include stdio.h, that's a header file for the library, and what it does is basically I'm telling the compiler whenever there is a hash, I'm telling it to actually delete this line. Okay, and in the machine code, go and get me the machine code of stdio.h, this library, and paste it into the top of my machine code. Okay, so it's copy from the library and paste it into my machine code. So what happens is when you do this, all the functionalities that are there in the library becomes available for you. Okay, so you can actually use those things in it. Okay, so the stdio.h will take the library and kind of put it over here, and I'm going to come in details in a second in this. Then we have an int main void. Okay, and this is very important. Any C program has a main function. Okay, so the main function, this is a function header, and the main function, each C program is the main function. Why does it always have a main function? Because this is the first function that gets executed in any C program. Okay, so the compiler, after it compiles and generates an exe file, when you run your exe file, the first thing that the compiler or the machine is looking for the main, and it's going to start executing your program from there. Okay, now we talked about this, so let me explain a bit over here. This is called the return type, the integer. This is the return type, so I'm going to put it over here like this. This is return type, and this is the function name. Okay, so I'm going to take it over here. Okay, and these are the input arguments. Or I'll call them the input for now. Okay, so int main void. What does void mean? Void means nothing. So this is what I'm telling the compiler. You have a function, and the name of the function is main. It takes no inputs, nothing. It takes nothing. You don't have to wait for an input for it to start. and it will return an integer variable for you. Now keep the integer variable to return for a second. I'm going to talk about it in 5 minutes. So when you run, the compiler is going to start by looking at the main, and then it's going to see that it takes no input. Okay. Then you have these two curly brackets over here. Okay. So the curly brackets over here indicate the start of the main function, and this indicates the end of the main function. So you'll have int main void, open curly brackets, close curly brackets. This is a part of the program that you must write in any C code. Okay. Now you have the curly bracket open, you have the curly bracket closed, and it tells the compiler that anything that is written between these two curly brackets are for the main program. Okay. So int main void, you open curly brackets and you close the curly brackets. So inside it, you put all the instructions that you want your program to do. So any instruction you want it to conduct, you put it inside the main. So for here example, we have a function over here called the printf and hello world. What is printf? Printf is a function which is inside this stdio.h library. And inside the stdio.h library, there are many functions. One of them is printf. What does the printf do? It prints something on the screen. Okay? The printf function prints anything that is between these two double quotes. Okay, so you see this double quote and this double quote, it will print whatever is between them onto the screen to the user. Okay, as it is written over here. So it's printf, and you open the bracket, and then you put the double quotes, and then you start write hello world exclamation mark. So it's going to start writing HELLO space WORLD exclamation mark onto the screen. Then you have the /n. The /n is a new line character. Okay, that is equivalent in a word processor pressing enter. So I'm actually asking it to press an enter. So it's going to type hello world, and then it's going to go back to the beginning of the screen and stop there, so that if you wanted to print anything else, it's going to print on the new line. Okay, so this is hello world. Now, very important thing is that every line in C, every instruction in C actually ends with a semicolon. So when you finish the printf, you have to put a semicolon. Okay, that is indicating the end of the instruction for the compiler. So the printf hello world /n between the two quotes and semicolon is a single instruction that I'm giving to the compiler, and the compiler is basically going to go and print for me hello world onto the screen. Okay. Then when we finish, we have to write return 0. Now we set an int over here, so we have to return an integer value. What's an int? An int is an integer number. An integer number are whole numbers like 1, 2, 3, 4, minus 1, minus 2, minus 10, minus 1 million, minus 5 million, minus 5, 6, 7, 8, whatever whatever whole number that you have. These are the integer numbers. Okay, so just from math, the integer numbers. Okay, or the number. One example is 1.1 is not an integer number. Okay, so you don't have a decimal value in the integer numbers. So you return, and between brackets you put 0. Okay. Why do we return an integer over here? We return an integer in the main function just to tell the operating system that we have finished working. Okay. So when your program runs, it comes to int main void is going to run, and you're going to return 0 when you finish. You're going to tell the operating system, hey, I finished normally. Please. I am exiting my program, now you can destroy my memory. Okay, so in the int main void you have to have a return 0. Now there are different ways of writing return 0. You can write return between brackets 0, or you can write return space 0 semicolon, and it's going to be the same thing. It doesn't matter, the compiler understands both languages. Okay, so every C program has a main function. The printf is also a name of a function, so printf is a name of a function, and it is inside the stdio.h. To use this, you have to include stdio.h in your source code, okay? So to use the function of printf. Now, going further, any general program in C has a preprocessed directives. It has the main function heading, then you have the two curly brackets, the open and close, and then in it you have all the instructions that follow the main function. And in the main function, usually you have to declare the variables, so there's declaration, and then there are the executable statements. Now the preprocessed directives are instructions to C processor to modify the text of C. Okay, so we talked about it, just like the hash include. It actually deletes that line, and when going to the machine code, it actually takes the entire machine code. It takes the machine code off the stdio.h and goes and puts it into your machine code on the top, so you can actually have all the functionality that is in it. Okay. Every variable in C has to be declared prior to use it. This is very important. If you are going to use any variable in here over here, you first have to declare it, then use it. Okay. Executable statements are translated into machine languages and eventually executed, and executable statements perform computation on the declared variables or input-output operations. Okay, so that's basically what all the instructions are going to do. Now we come to the example. Okay, this is the example we actually talked about, and this is the example of converting from miles to kilometers. Okay, so I showed you this code in the first lecture and I said I won't go in details. Now we will go in details and we're gonna talk about it. So the first line over here is a /star, and this is a comment, so this is going to be ignored by the compiler. Okay, the second line is in hash include, and between the brackets we have stdio.h, so I'm including the standard input output library. So in the machine code, what's going to happen, it's going to copy the machine code of the standard input output library and put it on top in my machine code. Okay, so I will have all the functionalities that are there in the stdio.h library. Okay, this is again a comment, so it's going to be skipped by the compiler. Then you have a hash define, and I said whenever you have a hash, that means it's a preprocessed directive. Okay, when a preprocessed directive, what does the hash define do? It defines constants for you. Okay, so for example, the way you write the hash define is you write hash define space variable name space the variable value. Okay, and this is how you write it in C. So hash define, an example over here is KMS underscore PER underscore mile. The value that I wanted to take is 1.609. Now what this is going to do, the compiler is going to look at your source code, and whenever it sees KMS underscore PER underscore MILE, it's going to replace it by 1.609. Okay? Another example could be if you wanted to define pi. Okay? So suppose you are actually working for NASA and you wanted to put your code on a shuttle, and that shuttle was going to go on land of Mars. You cannot define pi as 3.14, because if you do that, the error accumulation will be so high that the shuttle, when it's going to Mars, for example, it's going to miss Mars maybe by something like 7,000 to 8,000 kilometers. Okay, so you have to have something that's very high precision. So in pi, you might be having, after the decimal point, you might be having 20 numbers. Okay, so instead of writing the pi always with 3 point and 20 numbers in your source code, you can hash define and put pi over here and put 3 point and put the 20 digits over here, so that it actually can take it and replace it in your code with that number. Okay, so you don't have to write the same number again and again. So this is the hash include and hash define, and then there is a comment, and it's going to disinclude the comment into the machine code because we tell it to skip that. Okay, so let's talk more about the preprocessed directives, or commands that gives instruction to the C processor. Okay, processor is a system program that modifies the C program. Preprocessor is a system program that modifies the C prior to its compilation. Preprocessor directives begin with always a hash and hash include or hash define. So over here I'm going to explain it to you once more. If you have hash include.stdio.h, what's going to happen in the machine code, okay, of my program, first the compiler is going to, the machine code is going to be empty, and then it's going to come, and when it comes to a hash include stdio.h, it's going to go to the machine code. So it's going to have the, this is machine code of my program, okay, and this is the machine code or the object file of stdio.h. Okay, so it is something like this, and there's something in it. So what's going to do, it's going to take this, copy the entire thing and put it into my machine code. So I'll have the machine code of stdio.h actually copied over here into my machine code. Now I will have all the functionalities in them. Then it's going to go continue compiling my program and generate the machine code and write it beneath it. Okay, and the hash define, we actually told you that it goes into the machine code and replace anything by the hash defined by the value that you have given. So this is defining constant. Okay, So hash include is used to include other source files into your files. The include directives gives a program access to the library. Okay, so the hash include gives you access to the library, so you can actually use the functionalities that are in the library. Okay, libraries are useful functions and symbols that are predefined by C languages. Okay, so there is standard libraries that you can actually use. There's stdio.h, time.h, string.h, and lib.h. Example, you must include stdio.h for using printf and scanf. We did not talk about the scanf, I'm going to talk about it next time. And we'll have hash include stdio.h inserts their definitions to your program before compilation. Okay, so they all put the compilation, they copy the source code into your code and then do the compilation. Okay, the hash define directive is an instruction to the preprocess replaces each occurrence of a text by a particular constant value that's going to be performed and compiled. So it's going to replace a value, replace a variable by a value. It's not a constant by the value. Example, hash define kms per mile is 1.6, or you can hash define pi, for example, 1.4 of 3.14159 or whatever digits that you like. Okay, and when you run the program, if you encounter pi, it's going to be replaced by this number. Okay, make sure that you copy the exact same name as you have written over here, and please understand that C is case sensitive, so if we write over here pi in capital, write it pi in capitals in the source code also. Okay, so it is case sensitive, so if you write in small, write in small. If you write in capital, write in capital. Now we talk about the comments. So everything shown over here in green is comments. Comments usually start with a slash star and ends with a star slash. Okay, so anything that is between slash star and star slash, we tell the compiler to ignore, jump over, do not even look at it. Okay, so this is something as a comment. So this is one way of writing a comment, writing a slash star and a star slash, and it will ignore everything starting from the slash to the slash. Okay, it's going to ignore everything and it's going to take it out when it's compiling. The other way of doing it is putting a double slash, and it's shown over here. Okay, the double slash ignores everything from the first slash till the end of the line. Okay, so then you have to write something new on the new line. Okay, so this is a comment, this is a comment, this is a comment. Everything in green is comment. Okay, now for example, if I delete this, okay, the comment is going to be going, starts from slash star, and it's going to go continue everything, make it a comment until it reaches a star slash, but this is a star space, so that's not an end, so it's going to continue actually to the star slash, and it's going to be happening over here. So everything from here to here is going to be commented if this was not there, if you deleted this way. So this is going to be a comment from here to here, so it's going to actually include the new line character and everything else until you find the star slash. Whereas the slash slash goes to the end of the line and the new line is not a comment. Okay, so it's always to the end of the line. Okay, let's move on. So, sorry, moving on. We are talking about comments. Provide supplementary information, making it easier for user to understand the program, but ignored by the C compiler. Okay, so you have the slash star, star slash, whatever is between this is going to be a comment, and slash slash goes to the end of the line and makes a comment. Comments are used to create program documentation. So if you want to document something, you want to put your name in it, you want to put something, you want to tell the instructor an instruction prior of compiling this, that for example you might need a special library, so you actually tell the instructor before compiling your homework or something that please include this library. This is where you have to write a comment. Okay, the start of the program should consist of a comment. This is a very good practice. That will include your name, the date, the version of the software, and a brief description. Okay, usually you have to do this before you do post code onto the internet or anywhere in any company that you work. Is very important to put comments. Okay, so always comment your code, and good programmers always comment their code. Okay, then comes the main function, int main void, and we talked about it. The int is a return type, the main is the function name, and void means you're taking no input. Anything between the brackets is the inputs of the function. So we tell the compiler that there is nothing that you're going to take, but you're going to return from me an integer variable, and the name is the main, and the main is the first program that is executed in your C program. And then you have the open curly brackets and close curly brackets, and all of these are instructions that you are giving to the compiler. Okay? So int main void marks the beginning of the main function where the program execution begins. Okay, very important. This is where the program execution begins. Okay, every C program has a main function. Every C program has a main function. If you don't put a main function, your program is never going to start running. Okay, the braces, the curly brackets, mark the beginning and the end of the body of the function. And then in the function you'll have the declaration of the variables where you actually declare all the variables that you're going to use, and then you have the executable statements where you actually perform the computations and the logical testing to actually come to the result that you want. Okay? And executable statements are the statements that are translated into machine language, and declarations are actually memory allocation that you're going to be using. Okay? So we're going to talk about it in a bit more over here. Okay. So here's what actually happens in your program, okay? So when the compiler starts compiling and the compiler goes line by line in your code, it will hash include stdio.h, so there will be a memory reserved for you. And in it, it's going to have on the top a machine code, okay? So the machine code first will have the machine code. This is the machine code. This will have the stdio.h machine code, and then it's going to have the machine code of the different program that you have. Okay, then you come into the main function and it will allocate a memory for the main function. So this is actually the main function memory, and it has the machine code which has the stdio.h and all the other things. And then you declare a variable double miles. What it will do in the memory, it will go inside the memory and it's going to create a variable space for you and name it miles. Okay, this is double miles. What does double mean? Double is a type of variable that can hold decimal value. Okay, we talked about integer variable. Integer variable is a variable that cannot hold a decimal value. It has to have a whole number. The double variable, on the other hand, can hold decimal values. Okay, so we define a double miles. Okay, so it will define a variable for you called miles. Okay, and this is the variable where we're going to store the distance in mile. Okay, this is our logical place where we're going to store the miles. So physically we're going to allocate a memory, and logically we're going to put into it a value of the miles. Okay, now notice over here I have a comma, and comma means that there is still more things coming. Okay, so for us as human this is one line, but for the compiler the instruction didn't finish. We're still going on the same instructions until we reach a semicolon. Okay, so a comma doesn't indicate anything. I have to go to semicolon, and then I tell the compiler to ignore this till the end of the line. So it's going to jump and it's going to continue over here and it's going to find KMS. Okay, so what it's going to do is going to go and allocate a space into the memory and call it KMS, which is kilometers, which is where we're going to store kilometers. Then we're going to have a semicolon, and the semicolon we actually stop. Okay, this instruction finished. This is what the instruction did. It allocated miles and it allocated kilometers memories into the main function, which has the which we'll use to store variables. Okay, to store values in. What are variables? Variables for me are just containers. Okay, do not be confused of the variables in mathematics and variables in C. Variables in mathematics are an unknown value. Variables in C are always known. Okay? In mathematics, when we don't know anything, we create a variable for it. In C, when we know something, we create a variable and put it in it. Why do we call it a variable? Because in the time of execution, the value of this is going to change. So you might put a variable into a memory location. Let's suppose we put 5. Then you're going to multiply it by 2 and store it in the same memory location. It's going to become 10. Then you're going to add 3 to it, and you're going to store it in the same location. It's going to become 13. So the value is changing. That is why it's called a variable. It can hold any value for you. So it is basically a container. Okay? So we ask the compiler over here to generate a container of type double and name it miles into the memory, and another container type KMS and name it KMS and put it into the memory, and the type is miles. Okay? You can actually generate as many variables as you want. Okay, you have to do and separate them with commas. Say miles, comma, kilometers, comma, variable 1, comma, variable 2, comma, variable 3, and we're going to talk about the naming convention and how you can actually name it. Okay, so this is about the variables. Now the variables, they are the memory cells used for storing programs data and computation results. Okay, variables value can change. Okay, so that's the thing, that's why we call them variables. Examples is miles and kilometers in the previous example. Variable declaration is a statement where you actually communicate to the compiler the names of the variable, the program, the kind of information, and the compiler goes and allocates a memory for you for them. Example is double miles, tells the compiler to create a space for a variable of type double into the memory with the name miles, as we did in the last slide. C requires you to declare every variable before you use it, okay? Because this is the container, and this is where you're going to store things in it. So do not store, you have to declare a container and then you store things in it. You cannot store things out of nowhere onto this something that you did not declare, okay? Now the last slide that we have today is about the data types. How many data types do we have? We're going to introduce you over here for 3 data types, okay? Data types are sets of values and sets of operations that can be performed on those values, okay? Integer stores an integer. Int stores an integer value, whole numbers, okay? So int, when you declare it, it stores a whole number. So it's like 65 minus 1, 2, 3, 4, 5, 0, 1, 2, minus 1, minus 5, whatever whole number that you have, okay? Double stores real numbers, okay? Numbers that use a decimal point, 3.1415, 1.2 e to the power of 5, which is equivalent to this number, or any decimal point, okay? Now the double includes the integer, as you know in mathematics. Okay, a car, C-H-A-R, car. A car is an individual character value, is a character, okay? So if you want to restore a single character, you can define a variable of type car, and you can actually assign to it a value of a letter, okay? So you can actually say, for example, over here, you can say car, CH, semicolon, and then you can say CH is equal to, and between single quotes, you put the letter that you want in a semicolon, okay? So over here, I declare a character, CH, and then CH is equal to A. I actually assign it A and put it between single quotes and put semicolon, and that's an instruction that will assign A to the CH, okay? It can be a letter, a digit, specific number, or anything else, okay? Arithmetic operations, plus, minus, multiply, divide, are compare, and compare can be performed in case of int double, okay? So you can do addition, multiplication, division, subtraction, and compare in case of integer and double. Compare can be performed in character data also, okay? So you can actually compare and actually add the character data also, okay? So with this, we come to the end of our lecture. I hope you enjoyed the second lecture, and I hope to see you at the third lecture, okay? See you.